Hello everyone, welcome back to the channel Future Force. Today, we're exploring a hypothetical yet incredibly thrilling and thought-provoking scenario that has captured the imagination of military analysts and defense enthusiasts alike. Imagine the mightiest warship ever built by the United States Navy, an advanced vessel representing the ultimate combination of cutting-edge engineering, stealth technology, and firepower, sailing confidently through contested waters. Now picture it suddenly becoming the target of a coordinated barrage of 12 hypersonic missiles, some of the fastest and most lethal weapons ever conceived. The stakes could not be higher. In such a clash of speed versus defense, offense versus survival, who would prevail? This is more than just an exercise in imagination, it's a glimpse into the future of warfare, where milliseconds and advanced algorithms may decide the fate of billion-dollar assets and hundreds of lives. From the moment you lay eyes on America's ultimate warship, the first thing that strikes you is its exterior. Every line, every angle of its hull is a calculated expression of stealth and survivability. The ship is massive, stretching over 600 feet in length, yet it doesn't resemble the traditional warship silhouettes of decades past. Instead of bristling with exposed guns and missile tubes, its surfaces are clean, smooth, and angular, designed to scatter radar waves in unpredictable directions. Its matte coating isn't just for looks, it's a radar-absorbing material that significantly reduces the ship's signature against even the most advanced detection systems. Above the main deck, faceted superstructures rise like the slopes of a stealth fighter, housing advanced radar and communications arrays inside protective domes. The deck itself conceals dozens of vertical launch cells beneath flush panels that open only when needed. Helicopter pads and drone launch areas are seamlessly integrated into the ship's rear, ready to support aerial and unmanned operations at a moment's notice. Step inside, and the warship's interior reveals a different kind of power, one rooted in precision, efficiency, and advanced technology. The bridge is a marvel of modern command and control design. Instead of a clutter of dials, levers, and old-style charts, crew members operate from sleek digital stations, each with high-resolution touch displays capable of showing everything from missile trajectories to weather patterns. The panoramic windows are actually smart glass panels, able to become opaque for tactical concealment or transform into augmented reality displays that overlay vital information directly onto the crew's view of the sea. The living quarters are compact but comfortable, a far cry from the cramped, noisy conditions of older warships. Thanks to automation and artificial intelligence, the ship requires a smaller crew than past vessels of similar size, which means each sailor enjoys slightly more personal space, better amenities, and reduced fatigue during long deployments. Even the hallways and workspaces are lined with shock-absorbing materials to protect crew and equipment from vibrations caused by high-speed maneuvers or nearby explosions. Performance is where this vessel earns its fearsome reputation. At its heart is an integrated power system that combines high-output gas turbines with advanced electric drive motors. This hybrid propulsion allows the warship to reach speeds exceeding 35 knots when it needs to sprint, while also enabling near-silent electric cruising for stealth approaches. But propulsion is only part of the story. The integrated power system can redirect massive amounts of electrical energy to weapon systems, allowing railguns, high-energy lasers, and advanced radar arrays to operate at full capacity without compromising speed. Its sensor suite is unrivaled, a layered system combining satellite links, over-the-horizon radar, passive electronic listening posts, and infrared tracking. Together, these sensors form a continuous, overlapping bubble of awareness that extends hundreds of miles in every direction. The ship can detect, identify, and track hundreds of potential threats simultaneously, from enemy aircraft and submarines to the blindingly fast streak of an incoming hypersonic missile. Now imagine the incoming threat. 12 hypersonic missiles, each traveling at speeds above Mach 5, maneuvering unpredictably as they scream toward the warship. These aren't conventional missiles that follow predictable arcs, they can weave, dive, and change course mid-flight, making interception incredibly difficult. Each one carries a destructive payload capable of devastating a large vessel with a single hit. The warship's safety features are designed specifically to meet such nightmarish scenarios. Defense begins at long range with advanced interceptor missiles, capable of engaging threats hundreds of miles away. These interceptors are guided by predictive algorithms that analyze the missile's path and adjust in real time to counter evasive maneuvers. If any missiles evade this outer shield, mid-range defenses take over launchers that fire faster-reacting interceptors designed for closer engagements. As a last line of defense,
The ship deploys close-in weapon systems, including high-speed rotary cannons and cutting-edge directed energy lasers, to destroy incoming threats in the final seconds before impact. But the warship's survivability is not only about stopping missiles, it's also about enduring hits if they occur. The hull is built from composite armor designed to absorb and dissipate energy from blasts, while internal bulkheads divide the vessel into numerous watertight compartments. Automatic sealing doors and fire suppression systems activate instantly if the hull is breached, preventing damage from spreading. Redundant power and communication lines ensure the ship can continue operating even if one section is compromised. Crew safety is enhanced by evacuation routes, blast-protected shelters, and emergency medical facilities designed for rapid triage in the event of an attack. What truly sets this warship apart is the way all these systems, offensive, defensive, and sensory, are integrated into a single, highly intelligent command network. At the core of this network is an advanced artificial intelligence system that doesn't just react to threats but anticipates them. Using real-time data from multiple sources, the AI can simulate enemy actions, predict missile trajectories, and recommend interception strategies in fractions of a second, far faster than any human could calculate. This predictive capability can be the difference between survival and destruction in a hypersonic missile strike. Supporting this AI are autonomous drones, both aerial and underwater, that can deploy instantly for reconnaissance, electronic warfare, or even interception missions. These drones act as force multipliers, extending the ship's reach and providing additional layers of defense against complex, multi-vector attacks. All of this comes at a staggering cost. The price tag for such a vessel runs into the billions of dollars. This cost includes not just the materials and labor to build the ship, but decades of research, prototype testing, and integration of bleeding-edge technologies. The investment represents far more than a single ship, it is a strategic statement. In naval terms, losing such a vessel in combat would not only be a financial blow but a significant hit to national prestige, deterrence credibility, and the ability to project power across the globe. This is why the stakes in a scenario like 12 hypersonic missiles versus America's ultimate warship are so high. So, who would win in this ultimate showdown? The answer lies in countless variables. The hypersonic missiles, with their speed, agility, and destructive force, represent a new era of offense in military technology, an era where reaction times are measured in seconds and interception windows are vanishingly small. The warship, on the other hand, embodies the pinnacle of defensive engineering, with multiple overlapping layers of protection, redundancy, and adaptive intelligence. In a perfect strike, launched from multiple directions to overwhelm the ship's defenses, the missiles might succeed in scoring hits. Even the most advanced warship can't guarantee a 100% interception rate against such a coordinated assault. However, if the ship's sensors detect the launch early, if its AI coordinates all defensive layers with flawless precision, and if its crew executes every procedure without delay, the vessel has a strong chance of surviving. Ultimately, this is the eternal duel between sword and shield, played out on the high seas at unimaginable speeds. Both hypersonic weapons and advanced warships are evolving rapidly, each in response to the other. What's cutting edge today may be obsolete tomorrow as new tactics, new materials, and new algorithms reshape the balance of power. For now, America's ultimate warship stands as one of the most formidable defensive platforms ever built, and 12 hypersonic missiles remain among the most fearsome offensive tools ever devised. Whether one can decisively defeat the other may remain an unanswered question, one we hope never has to be tested in reality. But exploring these scenarios helps us understand the stakes, the technology, and the human ingenuity that define modern naval warfare.